Welcome to the Forest Analytics Landing Podcast. I'm your host, Matt Russell. In this podcast, we'll talk about how data and analytics are transforming the forest products industry. We'll share how a research-based approach to analytics can empower your forestry organization to make better decisions with your data. Welcome, everyone. Today I want to talk about biomass and carbon. I received a question a few months ago asking, you wrote earlier that since half of biomass is carbon, I multiply by 0.5. So what's the other half of biomass? This is a great question. And I think that we often make the assumption that half of the biomass of wood is carbon. And that's a pretty good approximation. And it's a statement that provides an approximation about the amount of carbon in the wood. Obviously, as foresters and as professionals in the forestry industry, we're not counting the number of atoms. We're not weighing the carbon in the wood. What we really do is probably rely on equations that estimate the biomass from some commonly measured tree dimensions like the tree diameter, the height of the tree, the species of the tree, things like that are easy to measure. And then we calculate volume and biomass, and then we might assume that 50% of that biomass is carbon. Now, before I dive into the answer to that, I do want to kind of revisit the 50% rule and to really kind of assess how well it works. There was a paper published in 2018 by Martin and some colleagues that compiled a database of different wood concentrations for tons of different species across the world. And so what they found was that on average, for hardwood species in the temperate regions, the average carbon concentration was 46.5%. And that was across 111 different species. For the temperate conifer species, the average carbon concentration of wood was 50.1%, and that's averaged across 45 different species. And so right then you can think of, for the conifers in the temperate region, that 50% number, that is that 50% of the biomass is carbon, might work pretty well. But if we look at the average concentrations for hardwood species, at 46.5%, we might think that that's maybe not as good a representation of that half of biomass as carbon general rule. And so it's important to, I think of that not all species are equal in terms of how much carbon they contain relative to how much biomass they have. The amount of biomass and carbon can transition across different regions, across different forest types. And so it's important to be thinking of that 50% value might be a good approximation, but depending on species and location and region, it might vary quite a bit. But back to the question about, if 50% of the biomass is carbon, what's the other half? It's a great question. And so you might think back to middle school biology when you remembered photosynthesis and you talked about the basics of plant biology. Well, the other 50% of wood is mostly oxygen. And so oxygen is about 44% of the tree. The biggest source after that is hydrogen, and that's at about 6%. And then nitrogen is about 1%. And then there are a couple of other trace metals that you might find across in the wood. And so these metals might include calcium, potassium, iron, among others. And so mostly, if you look at wood, it's carbon and oxygen are the two primary sources, but also a lower amounts of hydrogen, nitrogen, and some other trace metals. And so although the chemical compositions of wood vary by different species and for different regions, these are great approximations for what that other half of the biomass is. The major components of wood being the lignin, the cellulose, the hemicellulose, they each vary in terms of the proportion of carbon that's found in them. And it's really a useful reminder of the unique chemical compositions of wood. I think too, especially thinking back to some of those numbers that, about 46.5% of the carbon of the biomass is carbon in hardwood species is important to remember there. And so as you might suspect, when we think about scaling these numbers up to represent population level estimates, maybe even estimates at a larger geographic area like a county or a large ownership or even a statewide level. Once you start to look at some of those differences in terms of the carbon concentrations for different species by using a more refined estimate for that species, like was presented in the Martin paper, you can have some vastly different estimates of biomass and carbon. And so really important to understand the implications of, instead of just using a 50% assumption, that is 50% of the biomass is carbon, understand that there may be differences in terms of the species that you're working with on a regular basis. And so I did a quick analysis, and I'll post this in the notes. But if you look at one state, I chose the state of Maine. If you compare even just using the 50% rule versus the 46.5% rule for the hardwood species, on average, there ends up being about 4% less carbon across the state by using the more specific carbon concentration. And so if you look at that, if you use the 50% carbon concentration, there'd be an average of 16.2 tons per acre of carbon. Whereas if you used the more specific concentrations for hardwoods and conifers presented in the Martin analysis, you end up with 15.6 tons per acre. And so a pretty big difference. Certainly if you're scaling that up and you're trying to look at things like change estimates and other values of carbon stocks that are associated with the forest. And so you might suspect that for stands and those areas with large trees with lots of biomass, and so you might think large diameter oaks, large diameter maple trees, particularly those hardwoods, these differences are going to be more apparent. And so I think I point this out to just show you that there are differences, and while we often assume that 50% of the biomass of a tree is carbon, there are other resources available depending on the species that you're working with, and I urge you to consider using them when you're thinking about your carbon analyses into the future. And so that's it. I hope this has been helpful in thinking about biomass and thinking about carbon and those basic assumptions that we often use in forestry. Thanks for listening to the Forest Analytics Landing Podcast. For more information on how data and analytics can empower your organization, visit arbor-analytics.com.